Salam and welcome everyone. So today we're going to be working on the question on the screen that says the enthalpies of combustion for ethene, C2H4 ethane, C2H6 and H2 gas are given below. So we've been given the enthalpies of combustion meaning reacting something with oxygen. So for example, the first equation that we have here, equation 1, is the combustion of ethene. Equation 2 is the combustion of ethane, and equation 3, as seen on the screen, is the combustion of hydrogen gas. So we've been given the different enthalpies of reaction on the right hand side. Now, this question, before I go ahead to completely read it out, it's actually a question from the exam packets of one of my students who needed help tutoring. And these are problems that we did together. So, anyways, now the question says calculate the enthalpy for the hydrogenation of ethene to ethane. So, the first thing you have to note is that we are going to be using Hess's law because this question is clearly three reactions that end up becoming one major reaction at the bottom. So Hess's law just simply states that the total enthalpy of reaction or total change in enthalpy of a reaction is equal to the sum of the enthalpies of each individual reaction step. So basically, the enthalpy of reaction of the hydrogenation of ethene to ethane is just basically going to be equal to like the sum or the breakdown of, well, the sum of each of the this reaction. Now you may be tempted to just add this up and that's about it, but that does not work because we have to like make sure our reactions are done properly and the steps are done properly. So this is just the general data, and from this general data we can start solving the problem. So to solve the problem, solution is for you to focus on each major molecule on its own. So, for example, now you've been given C2H4, H2, as well as C2H6. These are the three molecules that we're going to be focusing on to answer this question. So, the first thing you have to note is this: you've got C2H4, okay? C2H4 is the first molecule on your left. So, we have to compare the general reaction at the bottom with these three different reactions to solve this question. So basically, what we're saying is C2H4. I have to look for where C2H4 is in equation 1, 2, or 3, and wherever it is, that is the reaction that produces C2H4 or that has C2H4 as its reactant. So when we look at equation 1, we see that C2H4 is in reaction 1. So basically, since equation 1 for the data as well as the general reaction we're solving for are the same thing, meaning there is no situation where like one is in the product side, one is in the reactant side, or one has more molecules than the other. We're just going to leave it. So we're going to leave equation 1 as it is. So when we leave equation 1 as it is, we're just going to rewrite equation 1 again. So rewriting equation 1, we end up with C2H4 plus 3O2 would give you 2CO2 plus 2H2O. So yeah, so what you end up is negative 1.411 kilojoule per mole. So that's basically this right here. And now we're done with C2H4. So this is done. Now we can focus on hydrogen H2. So when you look at hydrogen gas, we can now compare this major reaction at the bottom with the data at the top. So the three different data, of course, because we've used equation 1 to solve for the first molecule C2H4, we're not going to use it again. So now we have to focus on equation 2 and equation 3. So looking at H2, you will see that H2 molecule is also not found in equation 2, but it is found in equation 3. So when we compare equation 3 with the major reaction at the bottom, we would see that H2, 2H2 and H2, when you compare, you see that the data has two times hydrogen gas than the reaction at the bottom. So what you have to do is to make sure that it looks, or you have to manipulate equation 3 to look like equation at the bottom. So basically what you're going to do is you're going to divide both sides. You're going to divide both sides of equation 3 or reaction 3 by 2. So for H2, we're going to divide equation 3 by 2. So when we divide equation 3 by 2, we end up getting 2 divided by H2 2 divided by, sorry, 2 divided by 2H2, 2 divided by O2, and 2 divided by 2H2O. So you end up with H2 plus half O2 would give you H2O. So you end up with negative 286. And the reason why you have negative 286 is just basically what we know, right? We know that when you are working with whenever you're working with reaction and you're dealing with like Hess's law or just enthalpy in general, whatever you do to the reaction, we're going to end up doing it to the enthalpy of reaction value, right? So, right, since we divided equation 3 by 2, we're also going to divide 572 by 2. And dividing 572 by 2 would give you negative 286 kilojoule per mole. So, negative 286 kilojoule per mole. So, that is the new equation 3. Now, we're going to go on to equation 2, or without saying equation 2, we're going to go on to dealing with C2H6 because we've successfully done ethene and hydrogen gas. Now we have to go to ethane that I'm circling. Anyways, so C2H6 is the next one. C2H6. So now let's compare the general, well, not general, well, yeah, kind of general. Let's compare the, what they call it, the reaction that we're given at the bottom with equation 2. You're going to notice that we have the molecule C2H6 at the major reaction we're solving for, and we also have that in equation 2. But the difference is that equation 2 has two molecules of ethane, while the equation that we're solving for, the reaction we're solving for at the bottom, has just one molecule of C2H6. That's one. Then two, the second thing is that equation 2, C2H6 is a reactant, and the reaction at the bottom that we're solving the for the enthalpy of hydrogenation for is in the product side, while equation 2 is in the reactant side. So there are two things that are going to have to happen. We are going to first of all switch sides. So this is the instruction: switch sides of the reaction and divide the reaction by 2. So the first thing, of course, is that we're going to switch. So that's the first part of the work. And then the second part is to divide by 2. So when we switch, we end up with 4CO2 plus 6H2O will give you C2C2H6 plus 7O2. So yeah, so you just switch both sides. Let's confirm that that's the same thing we have. That's perfect. And because we're switching, of course, we'll go from an exothermic to an endothermic reaction. So this negative 3120 kilojoule per mole becomes positive positive 3120 kilojoule per mole. So we're going to switch. When you switch the up the sides of a reaction, you are also going to have to switch the sign in front of the change in enthalpy value. So now we're going to end up with 3120 kilojoule per mole. Now let's not forget that we're supposed to divide the reaction by 2. So when you divide the reaction by 2, you divide each one of the molecules, or each one of the like moles in front of the molecules. Divide this one by 2, divide by 2, and then divide here by 2. So rewriting it, we end up with 2CO2 plus 3H2O would give you C2H6 plus 7 over 2 O2. So of course, when you divide it by 2, 3120 simply becomes positive 1560 kilojoule per mole. And you see now that we have successfully like written everything out, and you're going to be wondering like, this is taking time, what am I supposed to do? Well, you're getting closer to the end. This is just basically how it's done. You can see that we're given three different equations. We're given three different molecules that are key molecules in the reaction at the bottom, and three different reactions in the data that we're given. Now I want to quickly mention something just in case you have another question. And there are questions like this on my channel that I have done. So you can, if you notice, we're only dealing with ethene here, ethane as well as hydrogen gas. The reason why we're not dealing with any other molecule is simple, or we don't have any other molecule in the final reaction for enthalpy, is simply because they are more than one. So you have CO2 in equation one, CO2 in equation two, and then you have O2 in equation one, O2 in equation two, O2 in equation three, and then in equation one and two you have H2O and H2O. Whenever you have multiple of the same type of molecule in a Hess's law question, don't think overthink it. Just know that it's gonna cancel out at some point, or it's gonna be like maybe added up together as the final reaction. So don't bother yourself. Just focus on anything, like in this case, C2H4, C2H6, and H2. Focus on anything that is a major, what they call it, that is a major molecule, not necessarily the one that has more than one molecule at a time and that can either be cancelled out or added up or subtracted off. I don't know, whatever you want to call it. Do more problems and you see what I'm saying. So the next thing you're going to do is that we label this now as reaction 2. So this is reaction 2. So the next thing you do is we are going to add up all three equations, or all three reaction steps. So when we add up all three reaction steps, we have C2H4 plus 3O2 would give you 2CO2 plus 2H2O. So you have negative 104.11 kilojoule per mole. And then you have H2 plus half O2, okay, which is simply equation 3. We're going to add that there. Would give you H2O, okay. And then you have the value to be negative 286 kilojoule per mole. Next, you have 2CO2 plus 3H2O, which is just equation 2, would give you C2H6 plus 7 over 2O2. So, of course, that's positive 1560 kilojoule per mole. So, now let me quickly write out everything. So, you have 1, 3, and then 2. So one thing I want to quickly mention is that whenever you have the equations all written up and you're supposed to add equations, is for you to treat each molecule like it's algebra. When you treat each molecule like it's algebra, it's going to be easy for you to like work with it, right? So for example, now there are some molecules here that can easily cancel out, and it's like when you have, for example, x equals x is the same thing as saying x minus x equals 0. So naturally x equals x will cancel out, right? That's how it's done, because x minus x equals to 0, so naturally cancel out, provided they are in opposite sides of the equation. So what this is telling you is that in all of these three different reactions, for example, now in the case of 2CO2, molecules of CO2 is the product side for equation 1, but it is also on the reactant side for equation 2. So you can easily cancel this out because it's not going to be in the final equation. That's that I wanted to explain. Now, the next thing you have to note is this. You have 2H2O here, you have 1H2O here. This makes 2H2O and 1H2O. When you add them up, what you end up with is 3H2O. That is on the product side for equation 1 and equation 3. But on the reactant side of equation 2, you have 3H2O. That means you can just cancel out the 2H2O from equation 1 and the H2O from equation 3 from the product side with the reactant 3H2O from equation 2. So when you cancel out, we have successfully canceled out H2O, which is water. Now, what we have left is O2 on this side, O2 on this side for the reactants for reaction 1 and reaction 3. But then we have O2 again for reaction, what do you call it? For reactants, sorry, for product of reaction 2. So you're going to be wondering, what do I do? What do I do? What do I do? Well, this isn't hard. All you have to do is do the same thing that we have here. Half of O2, half of 2 is just basically 1. So half O2 is here is the same thing as having just simply 1 oxygen, right? And 3O2 is just the same thing as having how many oxygen? 2 times 3 is 6. So that's 6 oxygen. What I'm trying to tell you is, for example, say half O2. Well, there are 2 atoms of oxygen. So when you do half of 2, you end up with just one atom of oxygen. Or you can just simply do the mathematics and just cancel out 2 here and cancel out 2 here. You still just have one oxygen. So that's what I'm trying to do. This is the way you think about it when you have fractions as the number of molecules or the number of moles in a particular chemical reaction. Anyways, you have now, we've understood that, we see that we have 6 oxygen on the left side here, and then one oxygen on the left hand side here for the reactant side. Now you have 7 over 2O2. 7 over 2 is just 3.5. 3.5 times 2 is 7. Or you can just cancel out the 2 here, cancel out 2. So you end up with 7 oxygen. So on the left hand side, meaning the reactant side for equation 1 and 3, you have a total of 7 oxygen. And then the product side for equation 2, you have a total of 7 oxygen. So when you see that, all you have to do is just cancel out the oxygen because they have successfully been cancelled out. So what you have left in all of this is the C2H4, okay, the H2 on both the reactant sides for equation 1 and equation 3, as well as the product side C2H6 ethane for reaction 2. So when you add this all up, you end up with C2H4, okay, plus H2, okay, will give you C2H6 as I have properly circled. So now you might be wondering, okay, we are just basically rewriting the formula that we have up top. And you will be right. We're trying to calculate the best way to get this reaction that we're solving for. So when we have this and we see that our work that actually matches what we've been given as the reaction, sorry, as the as the main reaction that we're solving the change in enthalpy for, then you should feel comfortable with what you've been doing so far. So now to actually answer the change in enthalpy or the enthalpy change question, so you have change in HR of the reaction will just simply be negative 144. So this one that we had manipulated based on how we had to like work with each reaction, we'll bring them down. So that'll be negative 1411 kilojoule per mole, okay, plus negative 286 kilojoule per mole plus 10560 kilojoule per mole. So when you do that, you just input this information in your calculator to get change in HR negative 137 kilojoule per mole. So basically, what this is telling you that the enthalpy for the hydrogenation of ethene to ethane is negative 137 kilojoule per mole. So this is basically the answer to this question. You can see we did so much, but I'm just trying to do like a breakdown analysis so that it's easier for all the students. So anyways, if you have any questions, please make sure you put in the comment section. If you have suggestions or concerns, also put in the comment section. If you're confused about what I've done so far, try to rewatch the video. Lastly, I wanted to mention that I'm a tutor who helps students succeed in all their STEM related courses, whether you're in middle school, high school, or college. So make sure you email me at Shahabi Tutoring for all your STEM related courses. And I can assure you that I'm going to try my possible best to be the teacher or the tutor you need in order for you to succeed. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.